Explore Technology says hello to everyone. Surely, you all know that tunnels are a useful traffic solution that allows us to travel through difficult areas such as mountains or rivers. Around the world today, there are many modern tunnels that are several kilometers long, deep underground. To construct these tunnels, people have used massive, state-of-the-art tunnel boring machines that are huge, weighing thousands of tons and extending hundreds of meters in length, often likened to underground monsters. These machines can crush rocks, concrete, or anything found beneath the Earth's surface. In addition to boring tunnels, they can also lay concrete, construct shield linings inside the tunnels. Today, developed countries are constantly racing to design and manufacture these gigantic tunnel boring machines with various sizes. Let's explore with Explore Technology the largest and most modern tunnel boring machines in the world and how they have helped humans construct tunnels quickly. First, let's take a brief look at tunnel boring technology using tunnel boring machines. With this method, a large diameter tunnel boring machine is used to dig deep underground, cutting through mountain ranges and crushing even the hardest rocks. You may not know that the largest tunnel boring machine in the world today is the TBM-BTA, made in Japan, known as the monster under the earth. This giant machine is 99.3 meters long, 17.5 meters in diameter, and weighs up to 7,000 tons, with 6,350 tons of steel. It can move at a speed of about 10 meters per day underground. The entire TBM-BTA machine is a giant cylindrical shape, divided into 41 parts connected horizontally. At the front of the machine is a rotating drilling machine with a large wheel-shaped cutter. The machine is equipped with 260 ultra-hard steel teeth made from alloy, designed to quickly crush hard rock. Behind the drill is an electrical-mechanical system that provides power to the drill head. After the giant cutter is the slurry pipe, which transports slurry and debris to the rear through screws and a conveyor belt 1 meter wide. About 850,000 cubic meters of earth and rock will be moved out through this system. Independent of the digging and boring system, there is a system for assembling and cementing the tunnel lining. Thousands of precast concrete segments are molded into a curved shape. Each segment is 0.6 meters thick, made of reinforced concrete and high-strength steel, ensuring the tunnel's load-bearing capacity in the future. The process of casting the concrete molds takes place in a factory under strict supervision of engineers to ensure the best quality. These segments undergo quality checks before being delivered to the tunnel construction site. Once the segments pass the quality checks, they are transported by trucks to the construction tunnel. Each curved segment weighs up to 133 tons. A large mechanical arm at the side assembles these segments into the tunnel lining. Each ring formed is over 2 meters wide. The robot arm, under the control of workers, picks up each heavy concrete segment and assembles them quickly and accurately. Especially in areas with dangerous terrain and unstable soil that is prone to settlement, additional support structures are built to prevent collapse inside the tunnel, using reinforced concrete. To carry out this task, a thin fabric layer is used to separate the tunnel lining. This lining is waterproof and can withstand extremely high pressure. After the installation of these protective layers, steel mesh is then installed around the tunnel lining. This step is performed by powerful robot arms, which place the steel sheets in position as they did with the concrete segments. After the steel mesh is installed, the concrete pouring process follows. To pour the concrete into this reinforced structure, workers and engineers use a closed arch frame structure that can be contracted and expanded. Both ends are equipped with barrier systems to prevent concrete from spilling out. This structure supports the heavy fresh concrete. When the segment is fully assembled, workers and engineers pump the concrete into the lining. The process continues until the entire tunnel lining is fully concreted. Since the arch concrete segments are hollow inside, other machinery and equipment can still move through it without interruption. the concrete segments or debris continue to flow through the tunnel without causing any disruption as the machine moves inside the earth. A modern tunnel boring machine is made up of hundreds of thousands of smaller components. The installation of this machine can take several days. And did you know that thanks to these modern tunnel boring machines, tunnel construction has become much faster, reducing costs and risks during the process? This allows humans to build tunnels hundreds of kilometers long, deep beneath the Earth's surface. Dear friends, the tunnel we are watching here is the one beneath the S-Bay, located 1.2 kilometers below the seabed in Norway. With the ambition of building a road that connects two sides of the Song Bay, reducing travel time from 21 hours to only 10 hours, the Norwegian government has planned to construct a tunnel beneath the bay. After construction begins, this will be the first undersea tunnel that cuts through a mountain in the world. Unlike ordinary tunnels, this special tunnel will have sections that hang 30 meters underwater using giant floating barges that connect with the tunnel through sturdy supports. Now, let's explore the $25 billion underwater super tunnel of Norway with Explore technology. With the complex geography of sea and mountain terrain making it difficult to travel between certain areas in the country, Norway has joined the race to build the first floating tunnel in the world. Building the tunnel will face many challenges. Therefore, the tunnel will have two main parts, the floating tunnel under the water and the sunken tunnel under the mountain. The project includes 4 bridges and a rock tunnel 392 meters deep, with a length of 27 kilometers. The most ambitious part of the project is to build floating tunnels under the water, 30 meters below the sea level. The underwater tunnel consists of 2 connected tubes running through the bay, with floating platforms on the surface to keep the tubes from sinking, reinforced with connecting beams along the entire system. The platforms are far enough apart to allow large ships to pass through. Each platform is equipped with motion sensors, helping it balance in high waves. Each tube is designed with 2 lanes, one for general traffic and the other for emergencies or repairs. These floating tunnels are made from concrete, like regular tunnels, and are held in place by cables anchored to the seabed or connected to floating buoys. The cables and buoys are spaced to allow ships to pass through easily. The tunnel is designed to withstand the harshest weather conditions and natural phenomena like frost and tidal movements. Since it lies 1.2 kilometers under the sea, the construction is not affected by winds and waves. The project is expected to be completed by 2033. If successful, Norway could win the global race for similar projects against countries like China, South Korea, and Italy. And in Vietnam, there is also a tunnel that ranks among the top in the world. It's the Hai Van Pass Road Tunnel. Let's take a look at the longest modern tunnel in Vietnam. The entire Hai Van Pass tunnel project has a length of 12.047 kilometers, with a design speed of 80 kilometers per hour, including a main tunnel of 6.280 meters long and 10 meters wide for 2 lanes of traffic. The clearance height is 7.5 meters. An emergency tunnel runs parallel to the main tunnel and has similar length, with a width of 4.7 meters, connected by cross tunnels and escape routes for people and vehicles in case of an emergency. When the Hai Van Tunnel was put into operation, the dangers of traveling on the Hai Van Pass were solved. Traffic through the Hai Van Tunnel shortens the distance by half and reduces the travel time to a quarter compared to the mountain pass, bringing significant economic and social benefits. Today, the Hai Van Pass has become a popular tourist destination. Dear friends, you've just joined Explore Technology in exploring the process of constructing a tunnel deep underground using the giant tunnel boring machines. Besides TBM-BTA, there are many other large tunnel boring machines in the world. If you know of any other modern and massive tunnel boring machines, feel free to share with Explore Technology and the audience by leaving a comment below this video. If you found this video interesting, don't forget to give us a like and click the subscribe button on the top right of the screen. Goodbye and see you in the next video.